All right, so we're going to talk a little bit about kind of the beginning of algebra. Or we talked a little bit about a variable last time. A variable is a letter. Typically, we use x, and it can represent any number. Um, and if we have an expression, something like 3x, we can plug anything we want in for x, and we can execute the expression. So if x is 1, x is 2, x is 3, for each one of those, we're going to have different answers, right? If it's 1, we're just going to have 3. If it's 2, we're going to have 6. If it's 3, we're going to have 9. So it just depends. Once we go into an equation where 3x equals something, now we have restricted that x to a particular. And so in this case, x has to be 3 because only 3 times 3 is 9. All right, so we're going to talk about, now that we've talked about variables, we've talked about expressions. Now we're going to talk about a lot of different properties and axioms that can be used in equations. So the first thing that I want to talk about is what's known as distribution. Distribution. All right. So in your notes, and I'm going to use variables for this. If we have a situation like this, in which you have a number being multiplied by a quantity, we have what's called distribution. And what that means is this x distributes itself over addition and subtraction. Okay. So this would be x times the quantity y plus z becomes x times y plus x times z. Okay. So I'm going to prove this with numbers. If we say x is 3, we'll make y 5 and we'll make z 2. Okay. Let's see. All right. So we've got James just joined. James, were you here last Tuesday? I forgot to take roll 2 days ago. If you're talking, I can't hear you. You might still be muted. Let me know, James, if you were here Tuesday. Jose, I know you were. You're here today. And Legend, I know you were here Tuesday. You're here today. Okay. And Crossland is joining. Okay. Crossland, were you here on Tuesday? Just unmute yourself and let me know, or message me either way. Okay, so let's jump back in to this problem here. We're talking about distribution. Now here, if I were to execute this, we know how to do this. 5 plus 2 is 7, and then 7 times 3 is 21. Now, this distribution tells me that I can multiply this number times the first one in this quantity. So 3 times 5 would be 15. Plus, and now I'm doing 3 times 2, so that would be 6. 15 plus 6 is 21. So we've kind of just proved to ourselves by using an example that if we execute what's inside the parentheses and then multiply, it's the same thing if we distribute what's being multiplied across addition or subtraction. So this is the big thing to know. X times the quantity y plus z is always x times y plus x times z. All right. And that, of course, applies to subtraction. So if you have subtraction instead of addition, the same thing happens. We distribute the x. We have x times y, then x times negative z, negative xz. Distribution. Any question about that? All right, so let me work out an example of this real quick. 3 times the quantity 4x plus 7 minus 2. Okay, what do I do here? Notice inside here, I can't combine the 4x and the 7, okay, because I don't know what x is. However, I can distribute here. So 3 times 4 times x is what I have here, and I'm just going to write that out like this. Then I have 3 times positive 7, so that's 3 times 7. Now that I've executed that, I can drop the parentheses, and I have minus 2. All right, 3 times 4 times x is 12x plus 3 times 7 is 21 minus 2. I can subtract the 2 from the 21, but I don't know what x is. So, but I can subtract it from the 21. So that becomes 12x plus 19. I'll let you guys write that down. All right. So let's look at another property, another axiom. All right. We know that addition is what we call commutative. Okay. Pronounced commutative or sometimes commutative. And all that states is I can add things in whatever order I want. So x plus y is the same thing as y plus x. The other thing that's commutative is multiplication. X times y is the same thing as y times x. Division and subtraction are not commutative. Addition and subtraction are not commutative. All right, then we have the property of association. What's often called the associative axiom of addition or the associative axiom of multiplication, which we're not going to worry about that terminology as much as you need to know the word associative and you need to know the word commutative. Associative simply means that if I'm adding two or more things together, I can associate two things differently, and it still comes out to be the same. So for example, if this is 3 plus 5 plus 6, 3 plus 5 plus 6, let's say I put my parentheses here, which means I have to do that first. But over here, I'm going to put my parentheses over here. Okay, let's see if we get to the same answer. This becomes 8 plus 6, which is 14. And over here, we have 3 plus 5 plus 6 is 11. 14, or 11 plus 3 is 14. So we can, if we have a series of addition, we can associate those things as we please. Okay. All right, some of the stuff that I'm going to do here is going to seem really simple and really straightforward, but it's one of the things that students struggle with the most, and that is ones and zeros. Okay, ones and zeros are very difficult in algebra. It's going to look simple, but believe it or not, we're probably more than likely going to struggle with it. So the first one is known as additive identity. Additive identity. Okay, what is additive identity? That is x plus 0 is equal to x. So make sure you're writing this down. Additive identity, x plus 0 is equal to x. All right, next we have multiplicative identity. Multiplicative identity. X times 1 is equal to x. So notice it's getting the x back. In addition, in order to get the x back, we have to add 0. In multiplication, in order to get the x back, we have to multiply it by 1. All right, next we're going to talk about additive inverse. This is x plus the opposite of x is equal to 0. X plus the opposite of x is equal to 0. Vivian, were you here on Tuesday? I believe you were.
Yes, I was.
Okay. Let me make sure to mark Vivian as present real quick. Right. All right, so that is additive inverse. Any number plus its opposite will result in 0. Okay, so this would be like 3 plus negative 3. But x could also be negative. So x could be negative 3. And then we're adding it to the opposite of negative 3, which would be positive 3. So negative 3 plus positive 3 would also give me 0. All right. Now the multiplicative inverse. Multiplicative inverse. That is x times 1 over x is equal to 1. So the additive inverse results in 0. The multiplicative inverse results in 1. X times 1 over x is equal to 1. Right? If we took 5 times 1/5, that would equal 1. 1/5 5 times is 1. This also shows you x divided by x. Those cancel. You're left with 1. All right, any questions on the additive or the identity or the inverse properties or axioms? All right. Next, we have the multiplicative property of -1. The multiplicative property of -1. All right. It states that -1 times any number results in that number's opposite. -1 times any number results in that number's opposite. Now, again, this is not a difficult concept, but we need to make sure that we understand the language here. This is kind of what I'm focusing on right now. Remember that I'm using the word here, negative, and here I'm using the word opposite. And I'm doing this on purpose, okay? The reason is if I have a number and I'm looking at a minus in front of it, we understand that as -1, right? If it was like it is right now, super cold outside, let's say the degrees it's 1 degree below 0, that would be -1. We would say, hey, it's -1 degrees outside. But if it's in front of a variable, it's better to use the word opposite. Here's why. Let's say that x is equal to 7, okay? -1 times 7 is equal to -7. Everybody understands that. However, what if x was equal to -7? Well, now I have -1 times -7. Well, negative times a negative is a positive. Well, hold on. You just said up here it was -x. No, I did not. I said it was the opposite of x. X is -7. The opposite of x is +7. So that's why here we use the language of opposite. -1 times x is equal to the opposite of x. All right. And right below that, we're going to discuss the multiplicative property of 0. The multiplicative property of 0. All right. It states that 0 times any number will return 0. And that seems obvious. There'll be some situations that comes in very handy as we move forward. So make sure you have this in your notes. If you came late and don't have it, just I've uploaded the first 3 videos. So Tuesday's video and tonight's video have not been uploaded yet. Once I have those edited and up there, they'll be up there. Make sure you grab that for your notes. All right. Make sure we're on track here. All right. So let's continue. Now we're going to talk about something called the transitive axiom of equality. The transitive axiom of equality. A lot of words there. All right. First thing to notice is the word axiom. What does axiom mean? Now, you won't need to know this for anything that I am going to test you on, but just so that you're aware when we use the word like axiom, because it will come up in a lot of math classes. It'll be something that maybe on the ACT will kind of pop up, and you'll kind of just need to know what we mean by it. So axioms are things that we cannot prove, okay? So it's a property, formally, an axiom is a property that forms the basis of a mathematical system, and it is assumed to be true without proof. So, for example, the idea that 2 plus 2 is equal to 4, I cannot prove that. Okay, that's impossible to prove. Now you may think, oh, you just go grab 2 jelly beans and 2 more jelly beans. Now you have 4 jelly beans. And true, you can show that it's consistent with things that you find in nature, but there's a different concept in philosophy when we talk about a formal proof. And there are a lot of things when geometry, if you take my geometry class in the future, we'll actually look at formal proofs. And formal proofs have been part of mathematics since the ancient Greek world. And all formal proofs start with axioms. And axioms are things that we assume to be true. So this transitive axiom of equality is something that we assume without proof to be true about equality. Now, what are we going to be assuming about equality? We're going to be assuming that it is in fact transitive. All right. So let me pull up my notes here. Make sure I get the right thing because I lost my place. There we go. All right. So I want you to write this out. If x equals y and y equals z, then x is equal to z. Okay. If x is equal to y and y is equal to z, then x is equal to z. Okay, this is going to become very important, especially moving forward with solving equations. If two things are known to be equal, and one of those two things is equal to something else, then the two outside things are equal to each other. So if x is equal to y and y is equal to z, then x is equal to z. All right, so there's going to be three axioms of equality we're going to talk about. That's the first one. Here's the second one. This is known as the symmetric axiom of equality. The symmetric axiom of equality. And it says that if x is equal to y, then y is equal to x. If x is equal to y, then y is equal to x. Now that may seem obvious to you, and it should, because again, these are axioms. These are things that we are assuming to be true about mathematics that we can use for more complex applications, and we can build on our knowledge. Okay. Let's see. We just had Charlie join us. Charlie, you were here on Tuesday, or were you not? I did not take roll then. I apologize. You can either message me and let me know or unmute yourself and let me know either way. All right. Now the final one, number 3 of our axioms of equality, is the reflective, or actually reflexive axiom of equality. And when I learned this one, I laughed out loud. I literally did. I remember learning this in class, and I didn't think this was real, but it's true. It's called the reflexive axiom of equality, and it states that x is equal to itself. X is equal to x. But again, we're dealing with axioms, and axioms are things we can't prove, but we assume that they are true. All right. So those are the three axioms of equality. Now we're going to talk about there are two properties of equality. And let me pull out my formal definition for property so you kind of understand the difference between a property and an axiom. So again, an axiom is something that we assume to be true without proof. A property of a mathematical system is a fact that is true concerning that system. So you can think about what's a good way to explain this? The property of a human being, for example, a property of a being is that we breathe oxygen. Okay, when you're talking about a property of a human being, it's something about the human being, it's something about the thing, but it doesn't encapsulate everything that that is, right? So a property of being a human is that I breathe oxygen. A property of being a human is that I eat food. The property of being a human is that I communicate with vocal cords. Even if you can find, like, let's say that you have a particular human that can't speak, or that can't hear, or that only has one leg, or whatever the case may be, it doesn't take away from what we mean by human, right? What we mean by human are properties attached to that concept. So these are going to be properties that are attached to the concept of equality, even though it doesn't apply to every single equation. These are properties associated with equality. All right. So the first one is called addition. Oops. Addition property of equality. Addition property of equality. And it says that if x is equal to y, then x plus z is equal to y plus z. All right, there's going to be two of these properties. So the first is addition property of equality. If x is equal to y, then x plus z is equal to y plus z. So let me give you an example. Okay, if x is equal to y, let's say x is 7, and let's say y is 5 plus 2. Okay, those two are equal to each other. All right, 5 plus 2 and 7 are equal to each other. Okay, so we know that x is equal to y. Then x plus z is equal to y plus z. So if I add a z, let's say z is 3, right? If I add a 3 to my x, I have to also, on the other side of the equation, add a 3, right? 7 plus 3 is 10. And then this quantity here, 5 plus 2 is 7, plus 3 is 10. So the only way I can add something on this side of the equation is if I also add it on the other side of the equation. That's what's known as the addition property of equality. And you can kind of think about this, the idea of an equation, as a teeter-totter in which you're balancing two things, okay? So if you think about a teeter-totter and you balance, if you put 10 pounds on this side, this would immediately go to the ground. However, if you put 10-pound weights on both sides, it would balance. And if I add weight to one side, I have to add the exact same amount of weight to the other side in order to keep the balance, in order to keep the equation, or what I call in order to maintain the integrity of equality, we must add or subtract, multiply or divide the same thing on both sides of the equation. So same thing, if I were to take away 5 pounds, let's say, from one side, I would have to take away the same exact amount on the other side. Then that would keep the equation balanced. All right. So that's the first property of equality, addition property of equality. Next, we have what is known as the multiplication property of equality. Okay, multiplication property of equality. If x is equal to y, then x times z is equal to y times z. Right, and I'll use the same example or the same numbers as I did before, but this is the same concept as addition, but as it relates to multiplication. So if I have 7 is equal to 5 plus 2, and on the left side, I'm going to multiply it by 3. That means on the right side, I have to multiply it by 3. Well, let's see if this works. 3 times 7 is 21. Now here, I'm going to work this out two ways. One, I'm going to execute what's inside the parentheses first. 5 plus 2 is 7, times 3 is 21, so that checks out. But I also learned distribution. So what happens if I distribute the 3, since it's being multiplied by the quantity here? I can distribute this inside. That's 3 times 5 is 15. 3 times 2 is 6. And 15 plus 6 is 21. So either way, it works out. So here we notice that if I multiply something on one side of the equation, I must multiply the other side of the equation by the exact same thing. All right. Now, let's do some practice problems. All right. So before, or last time, we talked about if I had an equation like this, um, 27 is equal to 9x, you're logically thinking, okay, what do I plug in for x that makes that 27? Well, that's anybody know? Actually, let me have you guys do that. Somebody message me. Good job. 3. So 27 is equal to 9 times 3. Very good. Now I have a way to solve this with my new properties. So let me do it. Before I do this one, let me do another one that's, we'll start with some simple ones. So 5 plus x is equal to 7. I know that if I put a 2 in here, 5 plus 2, that's going to give me 7. But now that I have know these properties of equality, now that we kind of went over them, what I can do is I can say, okay, if I can add anything I want to both sides of the equation, I can subtract anything I want from both sides of the equation. So does the fact that I can do that, does that help me at all? Well, I'm going to subtract 5 from both sides of this equation. So I have 5 plus x. Now I'm going to subtract 5 from the left, and I'm going to subtract 5 from the right. So 5 plus x minus 5. The 5 minus 5 are going to cancel each other, and I'm left with x. And here, the 7 minus the 5 is going to give me a 2. So the same thing that I was able to get to logically, which was, okay, I need to um, put something in the x in order to get to 7. Okay, that's a 2. I can also get that by performing a minus 5 on both sides of the equation. And what we've done is we've done what's called getting x by itself. And we do a lot of this in algebra, where we add, subtract, multiply, and divide on both sides of the equation in order to get x all by itself. Okay? All right. So let me pick out another one for us to do. All right, go ahead and do this one on your own. 10 times x is equal to 40. What does x have to be? And the way that I can find this is if I come in here and say, okay, I can divide both sides of my equation as long as I divide it by the right number. So if I come in here and I divide both sides of the equation by 2, let's say, well, 10 divided by 2, that gives me 5. 40 divided by 2, that gives me 20. So I've made it a little bit simpler, but I haven't really gotten x by itself. So how would I do that? So if I divide both sides by 5 here, the 5 divided by the 5 becomes a 1, right? And then I multiply that by x. Over here, the 20 divided by 5 becomes a 4. Well, I know that 1 times x, according to one of my axioms, is just x. X is 4. And in fact, I can do that up here. I can take my 10x is equal to 40 and use the same idea. I'll divide both sides by 10 because 10 divided by 10 is 1, and 1 times x is x. Now, 40 divided by 10 is 4. So in one step, I was able to get there. So when you have a problem, so let's say you have 2.5 times x is equal to 7.32, right? And this is a little bit more difficult to come in here and say, oh yeah, I know exactly what x is, because that's not mental math that we do all the time. So what I can do in those situations is I can divide both sides by 2.5. I can take this 2.5 and I can divide out that 2.5, and I'm left with x. Now all I have to do is 7.32 divided by 2.5. And either you can do that in a calculator or you can set it up as long division. I won't do that right now. But you get the idea of what we can do and how we can solve these. So this comes in handy, these properties, these axioms, especially when we're dealing with numbers that are more complicated and a little outside of just a real easy, intuitive number. All right. So let me give you one to try on your own so you can do a little practice. What is x? Go ahead and message me when you figure it out. Figure it out. All right. We got some people that have figured it out. Good job. All correct answers so far. Good. So here, it's a little difficult to come in here and say, well, I don't know what x would be because 3 is actually smaller than 6. So it's not like this is an easy 2 or 4 or whatever. I've got to figure that out. So if I divide both sides by 6, right, because I can divide anything I want on both sides of the equation. 6 over 6 is 1. 1 times x is x. All right. Now 3 over 6. 3 over 6 is the same thing as 1/2. Or if you divided 3 into 6, that would give you 0.5. Both are acceptable. 1/2 or 0.5. All right, let's look at this one. 18.5 minus x is equal to 19. What is x? Actually, no, sorry. Make that a plus. 18.5 plus x is equal to 19. What is x? Whenever you have the answer, 18.5 plus x is equal to 19, go ahead and message me. Good, good. All right. So remember, we can add or subtract anything we want on either side of the equation. So here, in order to get x by itself, what I'm going to do is I'm going to subtract the 18.5. Okay. Now, you can either write it in line. That's how I showed you before. 18.5 plus x, and then a minus 18.5 is equal to 19 minus 18.5. All right. That can look kind of long and cumbersome. So the way that I like to do it, and this might help you out a little bit. If you have 18.5 plus x is equal to 19, I'm going to subtract 18.5, and subtract 18.5. That might look a little better to you. So 18.5 minus 18.5 gives me 0. So now I have 0 plus x is equal to 19 minus 18.5 gives me 0.5. 0 plus x gives me x. X is equal to 0.5. All right, let me give you guys another practice one. Let's do 1/4 times x is equal to 8. See if you can figure out what x is. This one you can do logically. It's a little bit more difficult that way, but you can do it. Or you could try to multiply something by both sides of that equation. All right, good. I've got some correct answers coming through. Good job. All right, so I'm going to show you several different ways to solve this. All right, so logically, how many fourths does it take to get 8? So you could even draw this out. So if I have 1, 2, 3, 4, 5, 6, 7, 8. All right. And if I divided each one of these into 4 sections, all right, here's 1/4. How many of these fourths do I need to have to get 8 wholes? Right? Well, I would need 4 per each one. Does that make sense? I would need 4/4 for one, another 4/4 for two, another 4/4 for three, so on and so forth. So I would need 8 times 4, which is 32. So 1, 2, 3, 4, 5, 6, 7, 8, all the way. My last one would be 32. So if I multiply 1/4 times 32, 32 1/4, that gives me 8. Okay, but this is a lot of work. It's a lot of work to draw these out to give yourself 8 holes, divide each of them into fourths, and then count how many fourths you need to get the 8 holes. All right, so what we can do is we can say, okay, I've got 1/4 times x is equal to 8. Since I can add or subtract, multiply, or divide anything I want on both sides of the equation, here I can divide. I'll divide the fourth. So 1/4 divided by 1/4 is 1 times x is just x. Right? 8 over 1/4. And here we have 8 over 1/4. Okay. Now, what do I do about this 8 over 1/4? Dividing by a fraction is the same thing as multiplying by an inverse. So 8 divided by 1/4 is the same thing as 8 times 4 over 1. Now, I've explained this before, but I'll do it again because this is a really good thing to remember. If I had 8 apples, right? 1, these are going to look like terrible apples, but bear with me. 2, 3, 4, 5, 6, 7, 8. All right. If I went in here and I divided each of these by fourths, 1, 2, 3, fourth. If I did that to each one of these, each one of these would have 4 pieces. So if I took 8 and divided by 4, I've had 4, 8, 12, 16, 20, 24, 28, 32. So that's why you take this and you flip it to make it 8 times 4, which gives you your 32. Now I'll show you a third way to solve this. So continue to take notes. The more ways you can solve something, the better. 1/4 x is equal to 8. Here, if I multiply both sides by 4, right? 4 times 1/4 is 1. 4/4 equals 1. Or you can see that 4 over 4, because 4 is the same thing as 4 over 1. So you can see how the 4's cancel there. You're left with 1 over 1. Those cancel to 1 or is just 1. 1 times x just leaves you with x. 3 times 4 is 32. So no matter how we skin this cat, we're going to end up with x is equal to 32. All right, we're getting toward the end of our time, so let me give you a couple other practice problems here. Let's give you 7 minus x is equal to -1. Oops, -1. 7 minus x is equal to -1. What is x? Go ahead and message me when you have the answer. Okay. Interesting. Okay, we're getting a mix of answers here. So let's take a look at this. Um, what number would I need to put in here in order to get to -1? So if we look at this on a number line, if we start at 7, okay, how would I get to -1? 1, 2, 3, 4, 5, 6, 7. There's -1. In order to get to -1, I have to go to the left. 1, 2, 3, 4, 5, 6, 7, 8. X would have to be 8. 7 minus 8 is -1. The other way that I can solve this, and this is using the rules that I just taught you, 7 minus x is equal to -1. We're going to try to get x by itself. So I am going to subtract 7 from both sides. Okay? 7 minus 7 is 0. And I'm left with minus x is equal to -1 minus 7 is -8. So I have 0 minus x. That leaves me with a negative x, or the opposite of x, is equal to -8. Now here you might be tempted to say, oh, look, we have x by itself. You do not. You have this negative in front of it that we need to get rid of. Well, how do I get rid of a negative sign? I can multiply that by -1, because that'll give me the opposite. -1 times -x is just x. But if I multiply this side by -1, I need to multiply this side by -1. So -1 times -8 gives me 8.